Hello everyone. Welcome back to Power of NJ YouTube channel. I am Mani and NJ. So today we are going to see there is a two name dominated every agentic AI conversation. I'm having it right now. So LangGraph and UiPath. And almost every comparison you will find online puts them side by side like a competing product. Feature against features, tick against tick. That comparison is not usual to an architect, and the reason is simple. These two things do not sit at the same layer of the system. Look at the left of this diagram. Those graph nodes, a plan, a reasoning steps, a routing decision, a piece of moving between them. That is the framework for building the part of your system that decides what should happen. Now, look at the right. A robot, a workflow, and three enterprise application underneath it. SAP, Oracle, and legacy applications, any other application. That is the platform for reliably reliably making something happen inside system your business already runs on, including the ones that have no API worth calling. So, the question I want to answer today is not which one wins. The question is who thinks, who executes, and where exactly you draw the line between them. Because that line is the architecture, everything else is implementation detail. Here we are going to tear both the architecture down, rebuild them as a one hybrid design against a real invoice exception, and do the part most of the content skips. What happens when it fails? Who is allowed to approve it? And how you trace one transaction across two runtimes. Let's assume if you run a shared service center, you already have a few block invoices that person opens one at a time. Hold the pictures. That is the problem we are solving by end of this session, right? So the key message is not a product comparison, it's a boundary design problem. Moving into next. Now, here is the comparison you normally see: tool calling, memory, human approval, then whatever observation which we are doing. Both the platform gets a tick in every row. Now, tell me what you learn. You don't know who won the decision, who holds the credentials, who is the accountable when robot updates half of the financial record and losses its session. The table is true and completely useless because it describes features instead of responsibility. Now, look at the right panel. One side decides, right, what should happen. The other side controls how it will happen. So between them, there is a boundary, right? Is what you are actually designing. Watch the two lines crossing it. Sorry. One side decides right? The top line is the request the agent has decided on action is required and it is asking for it. The bottom line is the response coming back on its own separated path because a request and a response have a different failure modes and different logging needs. If you draw them as a one bidirectional arrow, you will design them as a one thing and then you will discover in production that you never handle the return trip. When I review an agentic design, this is the first artifact I ask for. It's almost never written. Consider you have a accounts payable process. The boundary is the difference between an agent that decides an invoice should be released and an agent that has direct right access to the ledger. Same capability on paper, completely different risk conversation with your auditor. Here is the key message: design the boundary first, then the platform choice follow from it. So now here, if you will see land graph, right? So land graph actually it will plan, reason, route, manage the state. Now here, when it is coming to specifically UiPath, it is executing, automating the process, integrated, and govern. Put those two halves together, and you get something neither side give you alone, which is enterprise agentic automation. Right? The agent decide what should happen. Enterprise automation executes what must happen reliably. So that is not a slogan. It is a division of responsibility with real consequences. It means the model is allowed to be probabilistic while the action stays deterministic. It means a bad reasoning step produces a wrong decision, not a corporate or corrupted ledger. And it means when auditor asks what changed in system record, you point at a job log with an execution ID, not at the chat transcript. So think you are the senior analyst or senior developer and a settlement operations team. The analysis decide the invoice should be released. The operations team execute the posting exactly the same way every single time. You would never merge those two roles into one person and remove the review. That is the same process, right? Here, the key message what we are bringing into the table. The agent decides what should happen. Automation executes what must happen reliably. Now, moving into next. Here, we are able to see this is the shape of land graph application. Start the plan, then reason, decide, then set the possible next step, then the state update, then either the next node or the end. What matters here is what matters here is It's not that the box exists, right? What matters that you wrote them. The topology is application code. Compare that to a generic agent loop where the model decides what happens next on every single turn. Here, the model influences which edge gets taken, but the set of edges is fixed, reviewable, and testable. Look at the three branches coming out, right? From our decide. Two are tools, and one is human. So, notice that human review is the node in the graph, not an email sent out the bank. This is the distinction of matters enormously later when we talk about resuming the work. Now, follow the rail on right hand side, state accumulate as the run progress. That means the next decision is made against the accumulated business context of the case, not against the last message in a conversation. And follow the written edge along the bottom back into the reason. Bounded iteration is what stops an agent from wandering. The graph can loop, but it loops on your terms and fixed numbers of times. Through a node you choose. Here, one of the example which I want to bring, right? In an invoice case, plan decides we need the purchase order and the good receipt. Reason interrupts the different ones. Both are in hand, decides, fix the branch. The human node only fires when policy says a person must look at it. Here, the key message I want to give you: the developer owns the topology, the model only influences which path is taken. So here, those five capabilities are worth naming preciously because each one of the decision you own. Right? See, here we have a different controls. One is for graph, second state, routing, tools, memory. Actually, what it does this in this graph, right? The graph is nodes and edge you declare. State is a type texture with reducer. So you can control exactly how each node made its results rather than hoping col- nothing gets messed up. Now, routing is a conditional edge, which means the branch condition is function you can unit test within a table of inputs. Tools are typed schema, so arguments are validated before anything happen outside your process. And memory has a layer with checkpointing that lets a thread pass and resume, which is what makes human approval practical rather than theoretical. One more thing before we go deeper, and I want to be explicit about it. Everything I label document, 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 right, is a published capability where I say interpretation, that is my architectural judgment, and you are feel free to disagree with it. Where I say conceptual, the visual is a teaching device, not a claim about somebody internal. I will hold that discipline for the whole session because in this phase, the fastest way to lose credibility is to confidently describe a platform internal that nobody has ever documented. So here, let's take one example. The routing point, right, is the practical one. If new exception type appear in next quarter, it is a code change with a full request and a test, not a prompt rewrite and a hope. Key messages. These five are design decision you own, not platform behavior you inherit. The climb legend is deliberated and that they should hold vendors, including you, to it. Now, here we are going to see boundary and the shape of UiPath agent. Here, if you will see, a UiPath agent takes a request, assume, building the contest, right? In the contest grounding and history decides which tool it needs and then reach into one of the three execution paths, an API through connector, a workflow, or robot driving an application directly. Here, underneath, those sits the estate that actually matters. Your ERP systems, the web applications, and the legacy desktop applications. Teams still use because it has been there for 20 years and nobody will fund replacing it. The important architecture, right, is on one on the left, decide and execute. The platform hold reasoning close to the automation. So identify permissions and logging to human tasks all come from one place. In a regulated environment, that is genuine advantage. And I want to be fair about it. The trade off is the control. When you are reasoning lives in a platform surface, first you gain governance and speed, and you give up some of the fine grind control. That is code first framework gives you. And notice the response land on the right, right? I'm saying right and right. So puncture you which you can see. So coming to here, that draws separately from the request. Every result comes back the same way. That is what makes the run auditable rather than successful. So here you can take any example for a mostly stable process with occasional judgment calls. This shapes is often the faster and cheaper answer. Not every problem need a custom graph. The key message UiPath keeps decision and execution inside one governed platform, trading some control for reach and governance. Now, here, if you will see, there is a two architectures side by side, and the difference in the center of gravity become obvious, right? So, left side we are seeing LangGraph, right side we are seeing UiPath. Coming into LangGraph, right? State defined your code, right? A graph with explicit topology, routing through conditional edges, tools as a typed side effect, memory as a checkpoint threads. Now coming into APAth, an agent managed by the platform, automation as a reusable process, robots that acts where no API exists, integration through connectors and queues, governance across identity, audit, and control. Now, read these two bars at the bottom because they are the whole slide. One side own the decision, the other side own the action. Neither list is a weakness. If your problem is mostly judgment over data, you can already reach the left column is wherever the value is. If your problem is reaching into 12 system reliably, the right column is where the value is. Most enterprise problem I see have a both characteristics. That is precisely why hybrid design keep showing up and why the boundary keep mattering. Take one of the key examples. Okay. So there is a customer onboarding is a good test for this. Deciding whether a document set is sufficient is judgment. Keying the customer into six downstream system is execution. Same process, two very different problems. Got it? So here I want to give you the key message. Land graph is strongest where decisions are made. UiPath is strongest where action land, right? So own current project on one side or whatever you want to prefer. Okay. So, and you can give a try for this implementation whenever you are doing your architecture. So moving into next here, specifically we are going to discuss about state management. So here the state management, if you are able to see, we are having node 146. So here you will get confused, right? Why node 1 directly it is going to node 4, node 6. Let me explain. This is what people mean when they say state, and it's far more interesting than message history. In intake, we know the case ID, invoice number, amount, and the exception, right? Everything else is null, and that is genuinely useful because null means not yet established rather than zero or false. After completing this intake process, moving into investigate, right? When we have started the investigation, here, if you will see, right, there is a purchase order in delta. If you are able to see, and the goods receipt was found, a decision to resolve, and a confidence value attached to decision. So now, after seeing these two states, right, here you are able to see the PO delta, grand found, decision, confidence. Everything is highlighted, right? Coming into after execution, the state carries the tool that was used, what tool has been used, and the execution ID, right, returned by the platform, the status as a new, new status, and audit reference. There is a three things follow from this. First, every nodes reads and writes name field, so you can test node in isolation. Second, the next routing decision reads business context rather than conversation text. And third, when this case is questioned 6 months from now, the state is the story of what was known and when it was known. The value of this illustrative, right? But the shape is exactly what I would put it into production. So here, if you will see why it is exactly matters. Each node reads and writes. The next node reads business context. Agents stay attached to the case. This is whole conceptual value. Here, taking one of the example, this is the difference between an agent that says it resolved the invoice and that can show the delta it computed. The receipt is found and the execution ID that proves the right landed. The key message was state is the business case in structure form. It is what makes both the next decision and the later audit possible. Moving into next. So here we have discussed as of now many things. Now, who is going to own the ownership of memory? If you will see this left side, right, state of your application defines the schema, the reducer, what nodes allowed to write, and which checkpoint backend to use, and you can unit test it, defer it, then replay it and version it alongside the rest of your process. One of your use case, whatever it is. On the right is the contest, the platform manager. Who is going to manage the platform? Actually, there is a agent history, jobs and queue records, execution logs, human in the loop part, whatever task they are performing, right? Here you can see you can configure and consume it. The platform guarantee the record of what actually ran, right? So now the reason is accountability. When the finance asks why an invoice was resolved, you need the decision inputs, and those belongs to your domain model. When audit asks what changed in the system, you need to execution record, and that belongs to the platform. Trying to make either both the jobs is where these designs get into your process. So I'm giving simple example. Account reconciliation make this is obvious. The matching logic and its rational are yours. The proof that the adjustment posted at 10:31 belongs to the platform that posted it. Okay. So the key message: first, own the business state. Second, consume the platform record. Third, never confuse the two. So now moving into next, I hope after seeing the you are more interested, right? So let me take walk you through this. Here, let's say there is a invoice exception arrives, and there are three explanations: a purchase order mismatch, a vendor issues, and are missing a goods receipt. In this run, the purchase order, right, is greater than zero. So the active root, this active root, right, is the mismatch path. Okay, any missing detail. There are other two are available but not taken, and I have deliberately muted them so you can see the decision rather than the diagram. Now look at the label on those branches, right? Those are conditions in code expressed against name fields in state. The model contributes evidence and a proposed classification. The branch itself is a function you can test with table of inputs. Here, the distinction matters enormously in your enterprise work. It means a regression is reproducible. It means a new exception type in a code change with the review. And it means an auditor can be shown why this specific case went down this specific path. Here, human review sits at the bottom, reachable from any branch, and it's entered by policy rather than by the model deciding that it feels uncertain today. So, example which I have seen, take a claim processing, has the same state: coverage lapse, documentation incompleted, or amount above tolerance, three named routers, each with on the owner and a service level, not one model improved. Okay. Now again. So I want to give some of the key message for this each slide. That's why I'm giving you routing blanks in a code so that every path is named, testable, and explainable. Moving into next. So here you are seeing right. What is the four layer memory and context? Taking one by one. What is working state? Working state lives for a single run and holds the live case. Right here, if you will see per run. Checkpoint live for the thread with what lets you pass from human and resume without losing the data. Knowledge lives at domain level. The policies and procedures you retrieve from ground the reasoning, and then the system record which lives permanently and decide what is actually true. Architects get into trouble when they let the agent treat its own memory as authoritative, right? If the model remembers that is the invoice was approved and the ledger disagrees, the ledger wins every time without discussion. So read the truth before you reason about it and write back truth a controlled path. There is a practical benefit to this layering as well. Most of us, what an agent needs in small, current, and cheap to fetch. Only a fraction genuinely requires retrieval or a model call. And separating the layer is what let you see that. The real world, what they are doing currently. Example, an agent that catches a credit limit and acts on it 2 days later is not being efficient. It's being a wrong at scale. So here, note this message. Agent memory supports reasoning. It never replaces the system of record, right? So in case agent would currently get a customer credit limit from ABC people and whether that source is authoritative. Everything the agent wants to do outside its own the process goes through a tool, and let us formalize that boundary properly. Okay, coming to here, there's something which I want to explain in detail. Okay, if you will see on the land graph side, right, there are four responsibilities. What is declare the tool and its schema, and validate arguments before the call, owns timeout, retry, and escalation. Merge the results in state, UiPath side, right? Four different responsibilities. Publish a process with typed argument. Authenticate and authorize the callers. Run the workflow or robot to completion. Return a structured and auditable result. Okay. Now look at what never crossed. that line, right? Credentials, selectors, screen logic, and application application on the automation side. The business judgment, planning, and case reasoning stay on the reasoning side. I labor this because the most common design smell I see is a leakage. A prompt that contains a system password, a graph node that knows which tab of which screen hold the tax code. The moment that happens, if you have coupled your reasoning layer to a user interface and every application upgraded becomes an AI incident. A tool calls an API boundary between two systems, but it is not a shortcut into somebody else's runtime. Across the world, if your finance system moves a field to a different tab next release, that should be a workflow change owned by an automation developer. It should never be a prompt change owned by a AI engineer. Here, key message for all of us, including me, keep credentials and screen logic, business judgment, and other. Right now, we can assemble hybrid architecture properly. Here, so a request arrives from user or a queue. What LangGraph does? Plan, reason, roots, then hold the state. When an action is required, it calls to layer, right? And notice how a path appears there as one tool among several sitting alongside your API and your knowledge source. That framing is matters because it keeps the automation platform in the role of an execution capabilities rather than the center of the universe. As we all aware, UiPath automates and executes the robot work inside the enterprise system, and the outcome comes back as a result. Now, follow this right column, right? Because this is the half that most architecture diagram gets wrong. The result becomes a state update. The graph then decide again with the outcome in hand. Either finish the case or escalate to a person. Two design nodes. First, the written path is separate line, deliberately request and response have a different failure modes and different logging needs. Second one, right? One correlation in ID runs from the first node all the way to last long line. Without it, you have two system and two stories. With it, you have one investigation. This is the diagram I would take to architecture team because it shows which team owns which box. Reasoning belongs to the AI team, execution to the automation team, and the contract between them is the things you govern. Key message: the hybrid works when the request path and the return path are both first class parts of design. The strip the diagram down to its principle and it becomes very simple, right? Here, the key architecture principle. Okay, land graph, things, plan, route, manage the state. But at the same time, a path, as all we are aware, execute, automate, and integrate. Now, it becomes a design test you can apply in any review. The agent decides what should happen, and enterprise automation execute what must happen reliably. So, if you are ever unsure which side a responsibility belongs on, ask one question: if this is wrong, do I get a bad decision or bad transaction? Bad decisions are recoverable with the review and iteration. Bad transaction, cost of money, trust, and sometimes compliance standing. Put the probabilistic work where a mistake is recoverable and the deterministic work where it is not. That is the whole principle. Deciding to write off 200 pounds difference is recoverable decision. Positioning that write off twice, it's not a decision at all. It's a defect with financial consequences. The key message: put probabilistic work where mistakes are recoverable and deterministic work where they are not. Right? The principles are cheap. So let us put this against real business problem. So here, if you will see, you have a 10,000 invoices. Okay, 18,000, let's say 10,000 or whatever number. Okay, there is a 8,000 against purchase order, right? Now, 219 for 17,000. At 1200 different. If you will see, 1200 is the difference. And the invoice cannot be posted. This is not a toy example. It is one of the most common exception queues in any SAD services center in the world. Here, what happens today, right? An analyst opens the ERP to read the purchase order, opens it again to check the goods receipt, sometimes open the third party application for delivery note, then decide whether the difference is an agreed price change or a partial delivery and genuine error. Then either post or correction or email the vendor. Now think about where the time actually goes. The reasoning takes a couple of minutes, then navigating and the waiting and the keying takes for longer than the thinking, right? So follow this six step, right? Which one need a judgment and which are purely mechanical, and this particular step is reasoning. This particular step is compare order against inward. So rest all are execution. The split is exactly the boundary we have been drawing all the session. Here I am taking example accounts payable manager watching this already knows their exception backlog number and how many people it occupies. That is the business case, and it does not need inventing. The business problem split naturally into judgment steps and mechanical steps. Now, here is how agent turns that case into executable plan, right? Here you can identify the exception type, check the PO number, check the good receipts, investigate the difference, decide the action, resolve them, right? So these six steps and every one of them is node with the name, right? And input and output and the failure mode. When a planner produce process, you get something that reads beautifully and cannot be executed, monitored, or resumed. When the planner produced is structured, every step becomes observable. You can see that step 3 failed and retry only step 3 and carry the rest of the state forward untouched. Now look at the tag underneath, right? Each node, so two reads tools, one reasoning the node, one conditional edge, and one execution call. That distribution is worth noticing. Most of the plan is reading and thinking, which is cheap and safe, and only the last step touch the system record. That is the step of well designed agent. A lot of inexpensive safer and a very small number of carefully controlled rights. If you count the rights in your own design and three or more than handful, that is usually a sign the boundary has drifted and the agent is doing bookkeeping that a workflow should want. A plan is only useful if each step in named observed unit of work. So now coming into your integration sequences, right? Read the top bottom. The graph node decide an action is required. Tool selection produce the validate argument and an identity key. right? The integration layer which we are seeing authenticates and start the jobs with correlation ID. The orchestrator dispatch to the licensed runtime. The robot logs in, search, update, and save. Then the reason come back the other way on its own land. Field values confirmed on screen, output argument, and an execution ID. The terminal job state, this particular terminal job state, right? It will result the payload. Your if you will see, it will result your payload and the results merged into state. Second, notice that every single hope carries the correlation ID. So when somebody asks what happened to invoice, if it is at 10,000, whatever number around 11 o'clock this morning, evening, no, based upon your hours, you do not go hunting through two systems with two different vocabularies and try to line up timestamp. You search one ID. Hope you got it right. The particular this key, right, is the line between a retry and a duplicate payment. If you take one implementation detail from this session, take that one. So here, every hope is explicit. Every response has its own land, and one ID ties the your whole call altogether. So here, what I would actually put it on right. So if you will go and see the request carries invoice ID, actions, reasons, what is the approval status, what are the correlation IDs, what are all the keys in the response. If you will see whether it's a success, failed, whatever it is, what is the invoice ID and what are all the different IDs and what is the current invoice status message. If you will validate all of them, what is not illustrative in these four rules on the right, valid in both direction because a malformed argument should never reach a robot and an unexpected result should never silently become a state. Carry on this particular key, okay? Then retry must not post the same correction twice. The carry correlation ID because that is your only realistic chance of one investigation across multiple platforms. No free text action. The model picks from the fixed set of named operations that single constraint bounds the blast radius of the bad decision by design rather than by supervising. The last rule is one of let your answer the question. Every risk officers ask, what is the worst thing this agent could possibly do with a fixed operation set? That question has a short and provable answers. Here, a type key correlated contract is what makes the model safe to connect the ledger. So now these are all the reference, right? How the three components: land graph, integration, UiPath, what are all the files I have been used, how I have authenticated, what are all the patterns I have been used. Now, the two patterns of bottom and both are legitimate. Okay, in the pattern A, the graph runs your own runtime and start job through the documented orchestrator API. In this particular pattern B, right? The same graph is packaged and published to the platform as a coded agent and runs under platform identity. The pattern A gives you maximum control of the runtime. Pattern B gives you platform identity, logging mechanism, and human task with considerably less interaction coded that you personally have to own and maintain. Choose pattern B when your constraint is governance and headcount. Choose pattern A when constraints, control, and probability. Both are defensible and the choice should be written down with its reason. The boundary is real code and there are two supported ways to deploy it. Okay, so let's map every architecture, right? So if you will come into this architecture, right, read this table, complete table, as the promise. Planner node maps the function and which maps to graph invocation, which produce this trace span and routing the maps to conditional edge declaration, which maps to a branch selection, which is visible as a decision field state. Tool node, everything already I have been explained, and here is how I would see this table if I were reviewing your design. This complete your design. If a box in your architecture has no row here, it's either decoration or it's a gap. I would say both are worth finding yourself before a internal review finds them for you. Run this exercise on your own architecture diagram. It takes an hour and it's the cheapest design review you will ever do. Every architecture component must map to code, a runtime, artifact, and a piece of evidence. Now, so these are all the transactions. If you will see automatically the plan created, now updated, now selected, job started, robot completed, and then result received, state updated, case resolved. Okay. These are all the illustrative benefit which I am telling. So if you are able to see, this is just a live run. How that case was running. One transaction, two times with same story. Okay. A good trace tells the story of one transaction across both the platform in a few lines. So this is general how the robot execution was happening. See, if here. Here five deterministic loop which I have used login, search, update, validate, save, done. Everyone those was designed, tested, version, and no model decides them at runtime. That is the entire point. That reasoning layer decides that this invoice should be resolved. So here, if you are able to see, the automation layer knows that is the particular application near that invoice number in the search fields needs the status changed before the amount is revalidated and needs the save confirmation check before reporting the success. So every organization has at least one application like this, no usable API, a vendor who will not prioritize your integration, and a team that depends on it daily. This is how you reach without preventing it does not exist. Deterministic execution is engineered, validated, and versioned, no model improved. So, coming to your next most important topic, failure and recovery. And so, this is the maturity and it earns you the most credibility. So, coming to the jobs runs, okay, robot work, the application timeout. Here, if you see system unavailable, what happened next in the critical design choice in this entire architecture, right? Now, the failure comes back to sector error with a code into state, and the graph decides what it means. There are three options, right? What will be the outcome? If the error is transist, retry with bounded attempts, the same key and backdrop between tries. If the path is blocked and but the goal is still valid, use an alternative another tool. If it is API instead of user interface or queue for later, and if outcome is ambiguous or final, escalate to concerned person with full trace attached. Now notice what we did not do. We did not throw an exception at the model and ask it to feel its way out. And we did not blindly retry. So, right, a retry business decision, repeating a right against a system that may have a half commitment is not recovery. It's the second incident with the same root cause. Yeah, duplicate supplier payments is very expensive way to learn this lesson. I have seen it happens because the retry policy was set at the HTTP layer by someone who had never seen the business process. Failure should not arise as structure state. So failure should arise as a structure state. Correct? So the graph can make a deliberate recovery decision. So here If you will see how that infrastructure timeout session, business tools block, and how unknown outcome fallback mechanism here. You have to use safe to retry, never tried, very fast, right? So this is in my experience, this third column specifically, right, is where most agentic automation incident actually comes from because teams implement two states, success and failure, and the reality has three, right? Very first is a single extra read call, right? Now it costs a fraction of second and it prevents the duplicate posting that would otherwise take a finance 3 days to unwind. Retry is a classification problem and unknown outcomes must be verified before anything is repeated. Now, here is the approval node, human in the loop part. Let's say, do not let the model confidence be your only gate. First, to value, then reversibility and audit exposure matters more. A low value reversible correction can run unattended at moderate confidence. A high value irresponsible payment should see a human even when the model is completely certain. Example, employee onboarding. Creating a mailbox is reversible and low value. Granting privileged system access is neither, and it should always see a person regardless of how confident anything is. So here if you will see approve, reject, ask for a details. It depends upon the your process. Human approval is first class node with evidence, a record and resumable path. Okay. Coming to security, right? This particular security. What are the identity and UiPath enterprise systems? The agent never speak to the enterprise system directly. Not once, not ever. Everything past the control point. Now the whole controls underneath. The agent runs a named service principal. So every action is attributable to something. Authorization is scoped to specific process and folders, not granted across the whole tenant. Secret live in credential stores, never in prompt and never in code. API security means short lived tokens, transport security, and code. The tools permission, right? Tools permissions read tool can be reliable, open, while write tools are explicit and view. Policy limits amount, vendors, and period. Audit records, who asked, what ran, and what changed. And human approval is required above policy threshold. None of this eight is exhaustive. What common and what I see repeatedly is finding three of the 18 place and calling the result six. So the scoping one cases people out and agent granted tenant wide job start permissions has efficiently been given. Every automation in your organization has a every build, including the ones nobody remembers writing. An agent reads enterprise system only through your security and authorization tools. Keep this in your mind. This is simply what are all the no platforms secure this for you, right? Uh, let's say this is just my interpretation of sensible split. Okay, and you should write your own versions for your own environment. Here, why it is worth the cover it takes, right? Incident do not happen inside these columns. They happen in the gap between them. The robot her rights nobody reviewed. The service principal outlived the project that creates it. The trace was emitted but never reached the logging pipe. No single platform closes those gaps and no vendor will do it for you. Let's take one example. The joiner and lever one in the slipper. A service principal create for POC 2 years ago. Still holding right permissions owned by somebody who has since left. That is not a hypothetical. Security is shared responsibility model and the gaps between owners are where incident live. So coming to this phase, right? If you will see this one graph run within 19 seconds, the inside node plan 1.6 seconds, the investigation, right? UiPath, jobs, everything was followed. Overall, nine. Overall, it took these many seconds. Now you can see latency 19 seconds and error 0. The execution ID is this, correlation ID this. How many tool was executed? 3. The underneath, the sixth thing I want on every screen, latency error, execution ID and correlation ID, tools and robot status. So graph this trace and job logs are separate system with separate vocabularies. The correlation ID is what turns them into a investigation. Build that plumbing before your first production incident because during an incident, nobody has the patience to join two systems by timestamp. Incident handling in the real test. At 2 in the morning, the question is always the same. What did this transaction do? And where did it stop? A correlation ID answer is in one query. So trace both runtimes as one transaction joined by a correlation ID. So here, this is general performance cost, how you are seeing, right? LLM reasoning, end-to-end latency, some of the four things, right? And the bars which it is shows, I usually see. It's not a benchmark, and I'm not going to front-end it as one. The one reasoning is fewer and better calls, not a big prompt. The graph is lean, state and single purpose node. Because checkpoint writes are not free, the API is catching tokens and preferring calls back over tight cooling loop. Okay. And the biggest sits on the right, you will see API path where one exists using the user interface only where you genuinely must. The last one point where architects earn their money, every screen driven step you can replace with an interface called take seconds out of the transaction and removes entire class of the same time. Measure your own transaction before you quote the number to business process. Automation execution usually dominates latency, and the biggest lever is choosing interface over this. Okay, now let me compare the screen, right? What is decide what, how to control. The model decide what, right? In this case, it decides that the invoice status should be updated, right? UiPath controls how authentication, the application, workflow, the robot, action, and validation. So read those two lists again because they split in the entire architecture. Every time you are attempt to move an item from the right list to the left, you are trading for flexibility in a place where the business is expecting determinism. Every time you move something from left to right, you are asking a workflow engine to make a judgment. It has no contest for. Get this line right, and both the platform do what they are genuinely good at. Get it wrong, and you inherit the weakness of both. The clearest test, which I may know, if you can't explain a business owner why a decision was made, too much has moved right. If you can't explain to your auditor how one action was performed, too much has moved left. The model decides what the automation platform controls how, make that split explicit. Now, this is one of the multi-agent extension high level. Here, if you will see, there is a planner, investigation, finance, path, human, right? When it helps, when it hurts. Multi-agent genuinely helps when the specialization are different, meaning different runs, different context, and different tool permissions. It hurts when you end up with more agents to debug than the business problem ever deserved. My thumb rule is to split an agent when its tool permissions or context needed differ, not because of a diagram looks more impressive with the five boxes than with two. The finance agent is the one what separating in practice because policy and tolerance change on the different cycle than investigation. Logics and are usually owned by different teams. Split agent by permission and contest, not for the sake of the diagram. Okay, so this is land graph only when the work is reasoning, retrieval, and orchestration of API. When every system you need already has a usable interface, And when the team owns the runtime and wants full control, adding an automation platform there are cost without adding risk. So UiPath only when the process is stable, high volume and rule based. When the value is reliable, execution and governance, and when the variation is low, that rules stay maintainable. Adding a reasoning layer there introduce non-determinism into something that already works perfectly well. Both when each case right needs a judgment before an action is chosen. When the action has to land in the system with no clean interface, and when the outcome must be covered and audited and be cleared high about the price of that choice, two runtimes, two failures, domain, and one sad trace to build and maintain. Here is my honestest. If you cannot name the reasoning that justify the agent, you are looking at an automation project with extra steps. Let's take document processing is often the land graph only answer. High volume of invoice posting with stable rules is usually the UiPath only answer. Exception resolution. Where you started this session is the genuinely hybrid. So combine two only when judgment and hard to reach executions are both genuinely required. So this is our whole system, how it is running, right? Let's say user build request, land graph plan and reason, root, and where API, knowledge source, a path sits by side as peers, a path to robots, the robot enterprise systems, then the results connected with your respective application back into the graph, the decision, and either human or complete, right? The three things to notice, the reasoning line are blue, right? The execution lines in the orange, okay? And return the line in dash. So anyone reading this diagram whole can immediately see which part of their organization owns which part of the system. UiPath appears as one tool amongst several rather than as the whole execution story, which is exactly how you want to this picture to look when you were present it to your internal team or wherever you want. And the written path, right, rather than implied, because that is the half of the architecture where teams discover, usually late, that they never design the errors handling. Take this one page into your next architecture review. If you the reviewers can tell you which team owns which color without you explaining, that diagram is doing its your job. One page, three colors, and written line that is designed rather than implied. So here overall architecture, what we have seen our five principles, one reasoning, It's not a execution. State must be explicit. Tools need that control boundaries. Deterministic work deserved and automation hybrid when completely demands it. The principle two is the one that changes designs in the room. The moment a team tries to print their case state and cannot, the redesign starts on its own. Right? Five principles and explicit state is the one that changes design the most. So now this is our overall architecture boundary. The important question is not whether LangGraph or UiPath win. The important question is where the reasoning should stop and deterministic execution should begin. When we design boundary correctly, right? The agent focus on deciding what needs to happen, while enterprise automation focus on executing it reliably. That is the where agentic AI starts becoming enterprise architecture. So if you are building this, one piece of practical advice, start with the contract, not for the framework. Write the tool schema, the correlation strategy, error classification, and the approval policy first. The platform choice become much easier once those four artifacts exist. And if this was useful, the reference, implementation, and full architecture pack will be shared with you. Okay, please tell me in the comment where you are trying your boundary, because that is the conversation actually worth to have. Four artifacts, one afternoon each, that is the fourth night of design work that will save your quarter of rework. Here, artifact the boundary and the platform debates resolve itself. So follow me for more content, subscribe my channel and give me your full support. See you soon. Have a great day. Thanks for watching my video.